Welcome to This Explainer. Look, if you're an infrastructure lead or an executive making the call on your company's AI future, you already know that keeping your hardware running at absolute peak efficiency is the whole ballgame. Today, we're taking a close look at NVIDIA Vera, and we're going to unpack exactly why the new age of agentic AI demands a fundamentally different type of processor to protect your bottom line.
All right, let's jump straight into Section 1, the agentic AI era.
For years, the data center processor playbook was super simple, right? You maximize the cores, virtualize them, and then slice them up to rent by the hour. It was all about division. But AI agents, these dynamic systems that plan and execute complex workflows, they completely rip up that old playbook. In this new age of agents, that traditional CPU architecture actually becomes a massive bottleneck. And if your CPU can't keep up, well, your incredibly expensive GPUs are just sitting there idle. Idle GPUs mean degraded token throughput, painful latency, and frankly, a huge drain on your ROI.
Which brings us to Section 2, the conductor and the orchestrate.
To really solve this bottleneck, we need a totally new mental model for our system architecture. Think of it like this. Your GPU is a world-class, incredibly powerful orchestra. It can produce massive compute power. But without the CPU acting as a highly capable conductor, managing the workflow, sequencing the tasks, keeping everyone on tempo, the music just completely falls apart. The conductor doesn't actually play the instruments, but is absolutely crucial to ensuring they perform flawlessly.
So what is this new conductor actually doing all day? It's managing what we call the agentic loop. We're talking about wrangling highly chaotic, unpredictable tasks. Branch-heavy Python runtimes, complex tool calls, secure sandbox code executions. It's a massive amount of intricate, variable work. And the CPU has to handle all of this perfectly, just to keep the GPU fed and computing without a hiccup.
Moving on to Section 3, breaking the CPU bottleneck.
So the big question is, how do we actually speed up the conductor to maximize your AI factory output? Enter NVIDIA Vera. This is a CPU built explicitly from the ground up for the agentic loop. It takes NVIDIA's custom data center CPU core, the Olympus core, and combines it with a highly scalable coherency fabric. It's designed to strike that perfect, elusive balance of performance, cores, and bandwidth, so your workloads never stall out.
Under the hood, the Olympus core is an absolute beast for throughput. You've got a neural branch predictor and this massive 10Y decode engine pulling in work at incredible speed. Then, a large out-of-order execution engine keeps those instructions flowing seamlessly. And finally, this is really cool. Advanced prefetchers equipped with a novel graph engine literally anticipate the next data path before it's even needed. Every single core is meticulously tuned to ruthlessly eliminate wait times.
But let's be real. Fast cores don't mean a thing if the data shows up late or corrupted. That's why Vera is the very first CPU to utilize LPDDR5X memory. This memory architecture is incredibly resilient. It can fix multiple errors simultaneously on the fly. And crucially, it does all of this without compromising your bandwidth. So it's built for reliability just as much as pure speed. And here's where we see the direct business value. By leveraging this memory architecture, Vera achieves a massive 40% lower peak memory latency compared to standard x86 systems. Just think about that. That 40% reduction means your cores are fed exactly on time through retrieval, analytics, and execution. Less waiting literally equals more processing. Plus, they completely rethought the physical layout of the chip itself to maximize speed. The old way of doing things, splitting cores across separate chiplets, actually, scratch that. It's not just old, it's inherently inefficient. Instead, Vera uses a second-generation scalable coherency fabric. It unifies all 88 Olympus cores onto a single monolithic mesh, while smartly keeping separate dies from memory and I/O. By eliminating those traditional chiplet boundaries and keeping everything on that single mesh, Vera delivers 50% faster core-to-core communication. It completely shatters the traditional CPU bottleneck. Those internal traffic jams that constantly plague legacy systems, they simply aren't an issue here. Let's wrap up with Section 4, massive throughput gains. Because at the end of the day, tech specs are great, but throughput is what actually pays the bills. Look at the sheer magnitude of the performance leap here. When you compare standalone Vera racks to standard x86 CPUs, Vera delivers 1.8 to 8 times higher performance when running agent sandboxes, tools, and data pipelines. Getting up to an 8x multiplier, that completely changes the financial math of your AI factory. And the crazy thing is, it scales even further. Vera utilizes memory-coherent NVLink chip-to-chip technology. It acts as the ultimate highway, removing all remaining friction by connecting the heavy-lifting Rubin GPUs directly to the fabric. And beyond just the GPUs, this NVLink tech can scale Vera up to multiple sockets, opening up massive, unimpeded bandwidth between the CPUs themselves.
Zooming out for a second, it's important to realize Vera doesn't exist in a vacuum. It's part of this unstoppable trio for the modern data center. In this new ecosystem, you have your Vera CPUs acting as the flawless conductor for those accelerated workflows. You have Rubin GPUs acting as the orchestra handling the heavy compute. And you have Bluefield 4 STX powering the context memory, AI storage, and networking. The whole shebang works in perfect concert for maximum output.
Which brings us to our final takeaway. To safeguard your investments and ensure your very expensive GPU orchestra never misses a single beat, you need to look closely at the foundation of your infrastructure. So ask yourself, as we fully enter this exciting age of agents, is your CPU truly ready to conduct, or is it still stuck in the past renting out cores?